Hello everyone, my name is Shanawaz Khan and in this video we are going to see the complex numbers in basics. So we will see the complex numbers, what are complex numbers, what are the operations done on the complex number. So let us get started. So from where the complex numbers comes? So if we want to find the roots of this quadratic equation or else this. So the first one can be resolved as x square minus 4x plus 4 plus 1 equal to 0, and this can be written as x minus 2 the whole square plus 1 equal to 0, and the second equation is x square plus 1 equal to 0. So x over here cannot be a real number because a square cannot be negative. So what happens? We take square of iota as minus 1. So we get iota as equal to square root of minus 1. Okay, iota is the imaginary constant, or we can say the imaginary unit. Okay, now, so if I take x square plus 1 equal to 0, I'll get x square as minus 1. So x will be plus or minus square root of minus 1, which will be equal to plus or minus iota. Okay, then moving on to the second equation, which is x minus 2 the whole square plus 1 as equal to 0. So x minus 2 will be either plus or minus iota. So x will be 2 plus or minus iota. So either x is equal to 2 plus iota or x is equal to 2 minus iota. So this gives rise to the complex numbers. This gives rise to the complex numbers. Now, how to represent this complex number? This is the set of the real numbers. This is set of imaginary numbers which are not real. Okay, so in imaginary numbers, these numbers comes. Okay, and in real number, all the real numbers are there. Okay, so this makes real number the subset of complex number. Okay, okay, so real number is a subset of the complex number. So let us proceed. So we are studying another kind of number which is complex number, which can be represented as a plus iota times b, where a will be called as the real part and b will be called as the imaginary part. Okay, now like operation on real numbers, there are operation on complex numbers as well. So there are four operations on a real number, which is addition, subtraction, multiplication, and division. Okay, now let us see addition. Any complex number can be represented by letter small z. Okay, so let us take two complex numbers z1 and z2. z1 is a1 plus iota times b1 and z2 is a2 plus iota times b2, where a1, a2, b1, b2, they all are real numbers. Okay, now addition of complex numbers. Okay, now let us add z1 and z2. So z1 plus z2 will be equal to a1 plus iota times b1 plus a2 plus iota times b2. Now let us take real parts and imaginary parts together. So this will be a1 plus a2 as the real part and iota times b1 plus iota times b2 as the imaginary. So we can take a1 plus a2 as a number plus iota times in the bracket b1 plus b2. So a1 plus a2 and b1 plus b2, they will be real numbers. So this is the addition of complex numbers. Now this subtraction. Now let us subtract z1 minus z2. So this will be in the bracket a1 plus iota times b1 minus in the bracket a2 plus iota times b2. So if we open the bracket, a1 plus iota times b1 will be as it is, and this will become minus a2 minus iota times b2. So again taking the real and imaginary parts together, we get a1 minus a2 in one bracket plus iota times b1 minus b2. Okay. Now, if two complex numbers are being added, the real part will get added and as well as their real imaginary part will also get added. And if we are subtracting two complex numbers, then their real part gets subtracted and their imaginary part also gets subtracted. Okay. Now let us multiply two complex numbers. Now let us multiply z1 and z2. So this will be in the bracket a1 plus iota times b1 times a2 plus iota times b2. Now let us expand this. So this will be a1 times a2 plus iota times b2 plus iota times b1 times a2 plus iota times b2. So this will be equal to a1 times a2 plus iota times a1 times b2 plus iota times a2 times b1 plus iota square of b1 times b2. Now iota square will be minus 1. So this can be written as a1 times a2 minus b1 times b2, and taking the imaginary parts together we get iota times a1 times b2 plus a2 times b1. So this is the product of two complex numbers. Now let us see division. But before division, let us do the reciprocal of a complex number. Okay, now let z be equal to a plus iota times b. So let us find what is 1 over z. So that will be equal to this. Okay, now to learn the reciprocal of complex numbers, we need to learn what is complex conjugate. Okay, now if z is equal to a plus iota times b, then its complex conjugate z bar will be equal to a minus iota times b. And when you multiply z with z bar, you get a1 plus iota times b1 times a2 a plus a minus iota times b. So this will be equal to a square and plus iota times ab minus iota times ab minus iota square times b square. So this and this will get cancelled. Minus iota square will be plus 1. So this will be equal to a square plus b square. Okay. So z times z bar is a square plus b square. Okay. Now to find the reciprocal. So find the reciprocal. We need to multiply both numerator and the denominator with the complex conjugate of z, which will be z bar. Okay. So this will be equal to a minus iota times b all over a square plus b square. And this can be split up as a over a square plus b square minus iota times b over a square plus b square. So this is the reciprocal of a complex number. Now let us move to division. So let us divide z1 with z2. That means z1 is being multiplied with reciprocal of z2. And since z2 equals a2 plus iota times b2, 1 over z2 will be equal to a2 minus iota times b2 over a2 square plus b2 square. So z1 times 1 over z2 will be equal to a1 plus iota times b1 times a2 minus iota times b2 all over a2 square plus b2 square. So let us simplify this. So this will be a1 times a2 plus iota times a2 times b1 minus iota times a1 a1 plus b2 minus iota square times b1 times b2 all over a2 square plus b2 square. Okay, now so this will be equal to a1 a2 plus b1 b2 plus iota times a2 b1 minus a1 b2 all over a2 square plus b2 square. Okay, so this will be equal to a1 a2 plus b1 b2 over a2 square plus b2 square plus iota times a2 b1 minus a1 b2 over a2 square plus b2 square. Okay, so this is division of two complex numbers. So in this video we saw what are complex numbers and what are the operations of the complex number. So this is all over. So this is all in this video.